And welcome to the 93rd episode of Rising Tide, the Ocean Podcast. This is David Helvarg of Blue Frontier and my co-host from the Inland Ocean Coalition, Vicki Nichols-Goldstein.
Hello, everyone.
Today, we're pleased to be talking with Dr. Mikki McComb-Kobza, Executive Director of the Ocean First Institute. A longtime diver and conservation biologist, Mikki's research has taken her to waters off of Africa, China, Australia, Latin America, pretty much everywhere on our blue planet. Working with hammerhead sharks, she's proved that, with their eyes way out on those stalks, they can still see straight ahead, also up and down. She's also mixed the old with the new, using lasers to measure the length of moving sharks and teaching others how to do it. So, sharks, 450 million years old, way older than us, lasers about 60 years old. But before we start hammering on about you and those odd sharks, Mikki, tell us how or when you first got interested in the ocean.
Yeah, well, thank you so much for having me. And I did get interested in the ocean and conservation in a weird way. I'm a Colorado native. I grew up in Colorado. And when I was 7, I saw the movie Jaws with my older brother and walked out of the theater forever changed because I was terrified of sharks. And I thought they were under my bed and under the kitchen table. I tried out for the swim team and I made it because I was swimming from sharks that were coming out of the drain. I really had a shark problem. And the only way that I really knew how to deal with it was to read about it. And luckily for me, my parents had an animal encyclopedia. And so I read all about sharks and I learned so much about them. And that fear was replaced with a fascination. And that fascination has never left me. I am just absolutely amazed by the story of sharks and their diversity. They're incredible.
I was terrified to see that movie, and I still have not yet seen it. I know all about it. I know the story. I know the biology and the history, but I know that sense of fear can be pretty dramatic. But how do you work to dispel that?
Yeah, I think for me, it was just, knowing and recognizing as a young person that what I thought was true wasn't. And it was, what I saw in that encyclopedia was people spearing sharks and that, they didn't understand their biology and, trying to explain and understand that, a good shark is a dead shark. It wasn't true that they had all of these different species that were on our planet and they had all of these different adaptations. And it just opened up the biology to me and the fascination that, these animals are older than trees. And it would just blew my mind. And I just had no idea that there were different kinds of sharks and some had hammerheads and some, were white sharks and some lived on the bottom. Just the whole suite of what I saw was really just something I'd never seen before. And it changed that fear. It just flipped it on a dime to me really wanting to know more. And I just couldn't get enough.
Okay, so a lot of kids, including in Kansas and Colorado, have a childhood fascination with dinosaurs or sharks, big, mean things that are bigger and meaner than your parents. And most of them don't turn that into a career. How did you follow it in through all your school years and sort of what happened?
Yeah, it's a great question. And I would say dinosaurs and sharks are almost the main line into science for kids. It's a great entry point, and it is that fascination. And, for me, it wasn't a straight line. And what ended up happening for me is I went into the business world. I kind of dabbled in college, but I wasn't really sure how to get to where I wanted to go. I wasn't maybe even sure exactly how to get to where I wanted to go. So I went into the business world and I did great. I was successful, but it was not very meaningful. And in fact, in my office, I had shark calendars and shark pictures, and people were like, "What's wrong with you?" I was like, "Well, I don't know. I can't seem to kick it." And a little bit later on in my business career, I had an opportunity that came to me to stop and sort of reinvent myself. And that opportunity, I sat down at the end of a dock and thought, okay, reach back to any time in your life and think about what you want to do. And I thought, the happiest time was when I was thinking about sharks. And so I thought, I'm going to go become a scuba instructor in the Florida Keys. And that's what I'm going to do. And that's exactly what I did. And it opened up my eyes to even more opportunities to go back to school, to become a marine biologist, and to really work for the conservation of these animals that just don't have the voice that I thought they needed.
You love sharks, clearly, and really just going through the whole gamut. So what are some of the key species of sharks and some of those characteristics, those unique characteristics that really inspire you?
Yeah. Well, I think for me, when I go diving and I'm swimming next to a shark and I'm able to look into their eye, what blows my mind is that you're looking back in time and you're looking back to all the different adaptations that have happened to this animal to bring it to where it is today. And every single species is unique. Each of them live in their own little microhabitat, whatever that is. And that has led to what you see swimming in the water today. And for me, just knowing that whole long evolutionary history, that it goes back to way before the dinosaurs, to before there were trees on the planet. It's really special to think about that long history. I think that's the lesson that they teach us, is that, there's so much about them that we still don't really understand. And we're losing so many of them before we can really understand some of the things that make them so unique. So in the Keys, I was spending a lot of time taking divers out to teach them how to scuba dive. And we were going to a lot of the same reef systems. We would see nurse sharks that were residents. Nurse sharks are site fidelic, meaning you see the same ones over and over again. So we had names for them. That was one of my first interactions, was just falling in love with these animals that you see time and time again. And then I started going to the Bahamas and doing, shark dives and seeing Caribbean reef sharks and tiger sharks, and, just understanding that they weren't there to come right after you to eat you, and experiencing that thrill for me was it was life-changing. And, it just fueled my passion to really go as far as I could to try to work on conservation, and had some chance meetings with Sylvia Earle and went diving with her on the Aquarius habitat for a whole week. And remember telling her my passion, and she said, well, who's stopping you? Why aren't you doing it? And I thought to myself, I was awestruck. And I thought, well, she's right. Who is stopping me? Me. So I ended up packing up and crying in my little U-Haul truck as I left the Keys, because I loved the Keys, and then went to Miami to go back to school. I was 28 years old. I was no young person at the time, but I didn't care, because I thought, I'm on a mission and I'm going to just keep going no matter what. And that was that. And
you studied sharks.
I did. So I got my undergraduate degree at FIU in Miami and stayed for a master's, and then moved up the road to FAU in Boca Raton to get my PhD, and then kept going up a little bit more and did a postdoc at Harbor Branch Oceanographic Institute, all working on sharks and just loving every minute of it.
Dare we ask what your PhD thesis was?
Oh, dare away. Yes. Hammerheads, studying all about visual capabilities of sharks. So their eyes, how and sensory system. So that was my whole thing. Sharks can smell, hear, taste, see, all the things we can do. Plus they have more, they're superior. And I got to study all that, and it was incredible.
I think it's so fascinating when you're talking about sharks, that some sharks are, they eat plankton, and then other sharks have these, pointy, terrifying teeth where they are major predators. And so I wanted to ask you, you're dealing with different kinds of shark and with the various senses. What are some of the biggest challenges? You're out there with these animals that can be 2 and 3 times bigger than you are. How do you manage studying them both in the field and in the lab?
It's a great question. Size matters, and it does make some of the studies that we do challenging, especially if we're doing things like electrophysiology, which is what I did to study visual capacities, electrosensory capacities. You have to take animals into the laboratory to do measurements to try to understand. And I would catch animals We would anesthetize them, just like if you're going in for an operation, you would get anesthetized, and we would do the procedure, and then we would revive the shark. And then after a certain amount of time of making sure they're okay, they would be released back into the wild. But it's hard to do that with large animals. So many times we would have proxies where we would use juveniles of a species to understand how fast their eyes work. What colors are they sensitive to? Can they detect weak electric fields underwater? How far out does that range of sensation occur? Can they detect it far away? What do they smell? What's their sense of smell? And it differs in different species and in different individuals. So you're really trying to get a snapshot of, eyes are important in this species. The sense of smell is paramount in this one. But it's all relative because they're using all of their sensory systems in combination. But it changes over a day, over a night, and over a lifetime. And that's what's really fascinating.
So two immediate questions on hammerheads. One is, how'd you figure out they can see straight ahead with their eyes way out on those stalks? And two, what the hell? Why are their heads like that?
This is my jam. Okay, so here's the story. So hammerheads, which you may not know, is that they are the newest sharks in the ocean. They're the most recently evolved sharks, and there are multiple hammerhead species, all of which have a different gradation of head expansion. So some are like shovel heads called bonnet heads, and then some literally are like boomerangs, and that's the winghead shark. And that has a limited distribution in Australia, of course. And so what's really cool, though, is the heads are all kind of, they expand out. And so the question that I asked is, what do they see around their heads? If they have a boomerang head, can they see straight ahead? So in order to answer that question, I employed a technique called an electroretinogram. And this is something you could get at a doctor's office. So the eye, our eye, shark eye, they're electrical organs. As light impinges on the eye, it sends an electrical signal down the optic nerve to the brain for processing of vision. It's an electrical situation. And you can put a little wire on an eye and you can detect that electrical signal of the eye. And that's what we did. We put sharks in water in a tank, we anesthetized them, strapped them down for a minute, and then shined light at all different angles around their head. And we were able to record the ERG, or the electroretinogram response. From that, we could create the three-dimensional visual field around their head. And from that, we were able to figure out that hammerheads have binocular overlaps, meaning each eye's independent visual field overlaps in front of their head. And it's believed that that evolved to facilitate depth perception. So you and I have frontally positioned eyes. That's typical of a predator. We can see really well. We can judge distances with our hands, so we can do things. If you're more of a prey-based animal, your eyes are more laterally positioned so that you can look for predators. You want to scan as much around you as possible to be vigilant against predators. So it was a fascinating study. We found that hammerheads have a 360 this way, and then on the horizontal field, they have these huge binocular overlaps of some were 10 degrees, and in the wing head with the biggest heads, they were up to over 40 degrees, which is a huge overlap, about 4 times bigger than regular pointed nose sharks. So this translates into a visual advantage for the hammerheads. And the hammerhead head, your second part of your question, why do they have it? That's a great thing to study, which I looked at. And there are many different reasons why the hammerhead may have arisen in the first place. It could have been a mutation that was retained and speciated out into all these other species now. The question is, though, the genetics are showing us that the big head came first, and that as hammerheads speciated out, they're going more towards a normal looking shark. So that may tell us that the hammerhead itself, the big head, may be maladaptive, may not really give them a huge advantage, but there are some definite positives, and one of those is the electrosensory system. Their heads are filled with electrosensors to allow them to detect prey. Having a huge head definitely, I think, conveys some advantage to them when it comes to locating prey. And we all know food and sex in the animal kingdom are the most important things.
They have predators. I'm just sitting here, my jaw is kind of dropping to know that it has such a broad visual experience, but do they also have to worry about predators coming up from behind them? Who goes
Sharks.
after hammerheads?
Sharks eat sharks. And so if you're a little shark, look out. Other sharks will take you down. And so that is absolutely what happens. And so having the ability to see, to be able to swim quickly, to respond. They have lateral lines on their bodies, which allows them to feel pressure changes and vibrations in the water. These are all the skills that the senses that these animals have in order to survive and to detect these predators. And so definitely bigger sharks are their predators.
So tell us, over the course of your career, how has the technology advanced your research in recent years? And are there any new tools or techniques that are really promising for some of the things that you're hoping to discover in the world of sharks?
Yeah, it has been amazing. We have just seen leaps and bounds in the technology that's been deployed in biological sciences to help us answer questions. One of the questions that I've been really interested in is in shark movements. So where do they go? And that's an interesting question because it helps us understand their life history and complete the picture of it. So where do they go to reproduce? Where are they mating? Where are they pupping? Where are they having their babies? Where are they breeding? These are all basic life history questions that we would know for animals on land, but we don't really know all of it for animals in the ocean. And so trying to figure that out is a tough thing because you're not always in the water and we don't have eyes under the sea all the time. So tagging and tracking is one way that we do that. And the tags that have been that we have to deploy on these animals have gotten smaller and better. And so some of the technology, there's two main types of technologies for tags. One is an acoustic tag that sends out a signal to listening stations underwater that allows us to really understand some fine scale movements where we set these listening stations down on the bottom of the ocean. And then we also have technology that we put on the animals that sends signals to satellites. And that allows us to understand real-time movements of these animals over vast distances. And so what we've discovered, perhaps in the great white shark, for example, is that they'll go from Nova Scotia to Louisiana and back in one season. And this is mind-blowing. We didn't know this information until just a few years ago because of being able to deploy tags on multiple large animals that are making these big migrations. And one of the other really cool technologies that I use in my research now, two really quick things. One is called eDNA, and that is all of us have DNA inside our bodies. Sharks do too. And sharks shed DNA regularly through feces, urine, and their mucus on their body. We can collect water at different sites, go back to the lab, filter that water out, and then detect the DNA of different sharks. And so I've been using that in our detection of great whites in the Northeast Atlantic. So I'll deploy a camera and I'll get a water sample, and that allows us to understand, are we seeing them on the video? And then who else in their DNA, who else is there? And it's just basically another layer of presence. So we can say, yes, we have white sharks here. We have another species of shark here through their DNA. So it's like a CSI lab, and the technology is getting cheaper. And we do that here in Colorado on some of the projects that we work on with fish and frogs. So it's across the board, a brand new, really powerful tool that we can use to understand the presence of these animals.
Well, it's almost like CSI meets sci-fi. And I have to ask you, because I got this image in my head, are you ever like underwater pointing lasers at large sharks?
Oh yeah, absolutely, all the time. I mean, we're measuring them. We use these twin lasers and we shoot them at the sharks to help us to measure their total length. And again, it's just one more layer of data. We have sex. We have size that can help us estimate ages. If we go to a place that has repeated, measures, these animals stay there for year to year. We can start looking at growth rates, which is really cool. So it's just another.
So wait, you're in scuba gear carrying like a waterproof housed laser beam?
Yeah, absolutely. Lasers.
Okay, where are the photos? Where are the photos?
I'll send you video and photo. You can have it all.
So we know that climate change is definitely impacting prey, impacting the populations, maybe mating, reproduction, rearing, the whole gamut. But what are some of the other threats to the shark population? And almost more importantly, what are the potential consequences if these threats continue?
Yeah, I mean, the biggest thing facing sharks is we're just removing too many sharks out of the water before they can replace themselves. And so that's really what's driving many species to become, critically endangered. Hammerheads, there are many species of hammerheads that are critically endangered, like pandas, or elephants. And that has just happened in the last 20 years. And again, it's just the removal of animals faster than they can replace themselves. And that's mainly coming from pressure from overfishing. And whether the reason is for shark fins, a lot of it is for meat. And we also have bycatch, but far and away, the biggest driver is overfishing. And the consequences of that it's really kind of an unknown. And I say that with a caveat, because I often go back to the example of Yellowstone, where we removed wolves and we saw, literally the stream flow changing because of all of the cascading things that happened with overgrazing and having wolves out. It allowed their prey base to overpopulate, overgraze, changing things. It's the same in the ocean. We just don't have enough information to really look at the broad ecosystem implications of removing predators. But sharks are the wolves of the sea. And so we know those principles apply in the ocean, but it's just that there's been so much removal over so long consistently that we just don't know what it means. But we do know that if we allow the ocean to have a break, it's resilient. So if we have the presence of predators, we know that indicates a healthy system. And that's why I fight for predators, because predators are just a very high level signal of a healthy system.
We have a pretty healthy population of white sharks here in California. It's problematic, but my attitude is if there's not something bigger and meaner than you're out there, it's not really a wilderness. And to have an intact marine wilderness is always interesting, always fascinating.
Yeah, I would say you're absolutely right. And in California and on the northeast coast of the United States, the white shark populations are increasing. And so they're really, they're not endangered species by any means. And so that's a great sign. And again, that's a victory for management. It's a victory for the Marine Mammal Protection Act, which allowed their prey base to come back. It's a victory. And whether people see it that way or not, it truly is ecologically a victory. When it comes to, you're talking about Florida, it is really interesting because right now, we saw, I think, 101-degree temperature in the water. And obviously that's very, very negative for corals. Corals are in big trouble right now, but it also applies to juvenile fish in the mangroves who are in this very hot water. It includes the sharks. And so the ramifications of these stochastic events, like these, huge heat waves, we don't really know what it's going to do, but we know it's not good. And an intact working ecosystem can take these things and it doesn't matter. But when you have a system already out of balance and then you have these things happen, those are the things that can push a species to the brink. And that's what we're worried about.
So you had mentioned a little while ago that if you leave the ocean alone, in essence, it can come back. And so I think you were alluding to the idea of marine protected areas and how important they are for different species, habitats. But how do the MPAs work when you have a shark species that really goes in and out of these MPA areas?
Yeah, well, MPAs definitely, as you know, are critical as these areas that allow species to rebound and to have an off limits area, just to give every species a break and the opportunity to rebound. The interesting part is yes, so sharks are moving in vast distances. Many of them are transatlantic, transoceanic, and so having a marine protected area in certain areas isn't truly effective for them as they're moving in and out of these boundary zones. And I think that's really part of marine protected area management and looking towards the future of really looking at the wide high seas and trying to understand that really is the place that we need to put some protections, because as we all know from the lessons of the tragedy of the commons, if you have an area that doesn't have laws, it's like akin to a college dorm room where there's pizza in there and everybody's going to go eat all the pizza until it's gone. It's the same with the ocean. Everyone is take because it's going to be gone and there's no regulation. That's the tragedy of the commons that applies towards sharks. That's why having these treaties on the high seas and these marine protected areas in these vast migratory corridors is absolutely critical. And that takes nations working together, and that is creating alliances and working together for the common good. And I think we're starting to see that progress for the first time in a long time. And I'm thrilled, because that's the recipe that we need in order to help our large pelagic species survive.
What advice do you have for individuals who encounter sharks while swimming or diving? And maybe this should also go to orcas. What do you tell them? How do they act in the ocean around these large, fascinating predators?
Yeah, well, so I study eyes, and one of the things that I figured out in my research, and we knew this, is that sharks' eyes are tuned optimally to kind of that twilight time. And so that's a time when light changes, the cast of characters in the ocean changes, and that's when sharks are active, because they have a natural advantage during that time. So don't go in the water during dusk and dawn. That's just a no-no right there. And also, if you go into an area where you see a lot of bait fish splashing around and moving around, that's what sharks eat. And so they're going to be coming in, and they're going to be hitting that, because they got to hit it fast, because they don't have hands. And so they got to catch everything with their mouth. They can't just feel stuff. And so they're going to come in and hit it. So if you see bait splashing around, get out of the water. Don't hang out there.
Mikki, this has been a delightful interview. Thank you so much for all that you're doing. I love that you are also in Colorado. So it's fun being your friend and your colleague, and we love your energy and enthusiasm. So good luck with everything, and we'll continue to follow you in all of your adventures.
Oh, thank you so much for having me as a guest. I really appreciate it.
Rising Tide is a production of Blue Frontier, co-hosted by David Helvarg and myself, Vicki Nichols-Goldstein, with support from Natasha Benjamin and Ellie Kurla. Rising Tide's editing services and technical support is provided by Studio Cape May. The theme song is written and performed by Ethan Kenbard. You can find Rising Tide, the Ocean Podcast, at bluefront.org, or download it from Apple, Google, Spotify, or wherever you get your favorite podcasts.
Off in the salty ocean, off where the waves roll free, the sparkling water rises, then crashes to the sea. Out amongst the breakers, you'll have no need to fear. It's true, it's the Blue Frontier. Off in the salty ocean, off to the Blue Frontier.
Sparky, come here, buddy. Sparky! There you are. Good boy, Sparky.